Form the partial differential equation by eliminating f from f of xy plus z squared, comma x plus y plus z is equal to 0. Let this be taken as the equation number 1. This is of the type f of u comma v equal to 0. Let u is equal to x plus y plus z squared and v is equal to x plus y plus z. The given equation is of the form u comma v equal to 0. To eliminate f, the formula is determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y is equal to 0. Now you find out the differentiations dou u by dou x. When you find out the differentiation dou u by dou x, you look into the equation u. The right hand side is, the first term is x into y. We are now differentiating with respect to x. Y is treated as a constant, the differentiation of x is 1. And the second term is z squared. You differentiate z squared once, it is 2z, and then differentiate z with respect to x, it is dou z by dou x, it is denoted here as p. Next, you differentiate the function v with respect to x. Look into the right hand side. The first term is x, the differentiation of x is 1, the second term is y. Now we are differentiating with respect to x, the differentiation of y is 0, and the differentiation of z is dou z by dou x, it is written as per notation p. Now you differentiate the given function u with respect to y. Now we are differentiating with respect to y. X is treated as a constant, the differentiation of y is 1. And the second term is z squared. You differentiate z squared once, it is 2 into z. Then differentiate z with respect to y, it is dou z by dou y, it is as per notation q, so that is 2zq. And the fourth term in the determinant, you differentiate the right hand side, the first term is x. Now we are differentiating with respect, x is treated as a constant, so differentiation of x is 0. The second term y, differentiation of y with respect to y is 1. The third term z, it is, the differentiation is dou z by dou y, it is as per notation, it is written as q. So 0 plus 1 plus q is equal to 0. Now you expand the determinant. So expanding the terms, 1 plus q into y plus 2zp, 1 plus q into y plus 2zp minus of 1 plus p into 0. So expanding this term, first you multiply by 1 y plus 2zp, it is y plus 2zp. Then multiply y plus 2zp by q, it is yq plus 2zpq, minus of 1 plus p is multiplied by x plus 2zq, minus of x plus 2zq plus px plus 2zpq is equal to 0. Now, expanding this term, we get y plus 2zp plus yq plus 2zpq minus x minus 2zq minus px minus 2zpq is equal to 0, and 2zpq gets cancelled, and p terms as a group, q terms as a group, and remaining terms are moved to the right hand side, and p into 2z minus x plus q into y minus 2z is equal to x minus y, which is the required partial differential equation. The second problem is form the partial differential equation by eliminating the arbitrary function from phi of z squared minus xy, comma x by z is equal to 0. Let this be taken as equation number 1. In this, let u is equal to z squared minus xy and v is equal to x by z. This is of u comma v is equal to 0. We already know the formula for eliminating the function. Now, to form the partial differential equation, we know the formula dou u by dou x, dou v by dou x, dou u by dou y dou v by dou I is equal to 0 determinant. So you find out dou u by dou x first. You look into the term u, dou u by dou x. The right hand side is z squared. First you differentiate z squared, it is 2 into z, and differentiation of z again, it is dou z by dou x, it is written as p. And the second term is x into y, minus of x into y. You treat minus y as a constant, the differentiation of x is 1. And differentiate the given function u with respect to y. Now the first term is z squared. Differentiate z squared once, it is 2z, and differentiate z once again with respect to y, it is written as q. The second term is minus xy. In it, minus x is constant, the differentiation of y is 1. And differentiating v with respect to x, it is u by v model. So denominator is v squared, it is written as z squared. In the numerator, the first term is v into differentiation of u. V is z, differentiation of x is 1, minus u into differentiation of v. U is x, the differentiation of v is dou z by dou x, it is written as p. Similarly, when you differentiate v with respect to y, again it is again it is the numerator is x, it is taken as a constant, and 1 by z has come. So first differentiate 1 by z, it is minus of 1 by z squared, and differentiate z once again with respect to y, it is q, which is equal to 0. Now you cross multiply as per determinant rule. It is 2zp and expanding the determinant, it is 2zp minus y into minus x cube by z squared minus of z minus px divided by z squared into 2z cube minus x is equal to 0. And as in the previous problem, you have to arrange the p terms and q terms and remaining terms on the right hand side, by which we are getting the differential equation as px squared minus q of q into xy minus 2x squared, which is equal to zx. This is the required partial differential equation.